All right. Shh. Guys, hush. All right, so we left off at page 29, so go to page 30. So just to kind of recap what we talked about yesterday, we started talking about radical graphs, so specifically square root and cube root graphs. All right, now remember with square root graphs, you're basically drawing them to where you won't have imaginary numbers, meaning under the radical kind of defines where your domain and range kind of is. All right, because, so for example, if you looked at that first example that's on the board right there, the x minus 1. All right, that means what has to be our lowest x value so we don't end up with a negative under the radical? 1, because 1 minus 1 is 0. All right, so essentially, whenever you're doing a square root graph, you would set whatever under the radical equal to 0, solve for x, and that will be your lowest x value that you can use. Or highest, depending on what it looks like. All right? Now, cube roots are a little different. Because with cube roots, remember, you can have negatives under the radical. Why? Right. Because if you multiply, let's say, negative 1 by itself 3 times, you're going to end up with a negative 1. All right? Because it's 2 negatives that make a positive. So if you multiply another negative to it, it turns it back to negative. So there's no such thing as imaginary numbers when it comes to cube roots. All right, typically their domains and ranges is typically all real numbers for both. Whereas with square roots, it depends on what's under the radical. All right, so let's look at the next example. So these are some cube root graphs. All right, now, the only thing about a cube root graph is that I kind of want to know where my vertex will be, meaning the center of that graph. All right, because if I just drew the parent graph real quick, so we talked about that yesterday. What's the parent graph, or what's the parent function of a cube root? Cube root of x, good. So if I just do the parent function real quick, all right, I have 0 in the center, that's the vertex, 1, 1, then 8, 2. And then on the other side, I would have -1, -1, -8, -2. So my graph will look something like this. So this is my parent function. So that's just the cube root of x. Now, what I'm talking about is the vertex, which is this point right here. It's kind of where it switches from being kind of where your y values are less than 0 to where your y values are greater than 0. All right. So this would technically be the vertex of that graph. Now, if I wanted to do this based off of function transformations, all right, so we talked about this yesterday. What transformation would happen between the parent graph and the current function that's up there? What do you think? So look at that chart from yesterday if you need help. But based off of what we start with, which is our parent function, to what we want, what do you think? What's it going to do? Go to the right 5. All right. So in reality, this whole graph is going to shift right 5. So let me just look at my vertex and see how I can get that. So If I shift to the right 5, I'm just going to go 1, 2, 3, 4, 5. So my vertex would be right here now. Oh. All right. So look at my new vertex now. How do you think I can find that based off of my graph? Well, yeah, it's because of the transformation. But if I didn't know the transformation, or I didn't know how to find transformations, how do you think I would find the vertex without having to do a lot of legwork?
Put it in the calculator.
Well, if you don't have a calculator. Look at the original function. What's under the radical? X minus 5 is under the radical. All right. What's the vertex? What x value is it at? It's at x value, not y. It's at 5. So how do you think I got 5 from x minus 5? You would set equal to 0, add 5 to both sides. So that's how you find the vertex, just like with a square root function, but with square roots, it finds our lowest x value. This, at the very least, will find our vertex. So if we set x minus 5 equal to 0 and solve for x equals 5, and that's the x value of the vertex. And then the y value, you would just plug the 5 back in and solve. So 5 minus 5 is 0, cube root is 0, 0. All right. So that being said, let's find some more numbers. So if we look at our parent function, all right, after we hit 0, we then went to 1. So what do you think after 5 we're going to go to? What do you think our next number is going to be? 6. So if I plug 6 in for x, I get 6 minus 5, which is the cube root of 1. What's the cube root of 1? 1. So I have 5, 0. I then went to 6. That'll give me 1. Now we'll probably go off the graph for when x is 8. But what value do you think would give me the same thing for x minus 5 that x equals 8 does for the parent function? So think about it. If you plugged in 8 in for x in the parent function, what should you get? You should get 2. So in other words, you need 13 in for x, because 13 minus 5 is 8. And that'll give you the other. So it'll go off the graph a little bit. But if we wanted to graph it, 11, 12, 13, up to 2. Now, opposite direction. So I need my negatives. So what value, if I plugged in for x and I evaluated, would give me a negative 1 under the radical? Four. So if I put 4 in, I'll get negative 1. What value would give me a negative 8 under the radical? So what value of x, if I plug that in, subtract 5 to, what value would give me negative 8? Negative 3. That would give me negative 2. So all I'm doing is comparing it to the parent graph. So the parent graph is this one. So 0, 0, negative 1, negative 2, 1, 2, 2, or negative 2, negative 1, and that's not negative 2, that's negative 8. 1, 2. All I'm doing is that the y values are going to be the same because there's nothing being added or subtracted or multiplied outside the radical. The only thing that changes is the x values. All right. So, in other words, I'm trying to figure out what x value would give me that same y value. All right. That's the way you can think about it. I just figured out which values would give me -1 under the radical if I plug it in a value for x and subtract 5 to it, and then what would give me -8 under the radical. So in other words, I'm finding things that would give me perfect cubes under the radical, because that's what you want to graph. You don't want to graph those funky irrational numbers. So whenever you're graphing a radical graph by hand, always shoot for trying to find perfect cubes under the radical. So your basic perfect cubes that you can always rely on, at least with these graphs, is 0, 1, and 8. All right, I doubt you'll see a graph where you have to go all the way up to like 27 or 64 or anything. All right, so typically 0, 1, 8, those are the perfect cubes you want to shoot for under the radical. And then the negative version, so 0, -1, -8. All right. Any questions on that one? So this graph would be the one that we originally wanted. Now, what do you guys think the domain of that red graph is? It's all real numbers. What about the range? All real numbers. Because again, there's no way you can get an imaginary number with a cube root because it covers your negatives and your positives. And even though it looks like it doesn't hit all of the y values, remember, its rate of change is very, very small, which means it's going up and down very, very slowly. All right. Okay, let's try example 5. So first off, I want to find my vertex. So before we even do that, let's rewrite this so it's a cube root. Because if you raise something to the 1/3 power, that's the same thing as doing what? Cube rooting it. So this is the same thing as negative cube root of x plus 3. All right. Now, first thing we're going to do, find our vertex. So that's the middle of our cube root graph. So how do I find the x value of my vertex? You would set x plus 3 equal to 0 and subtract the 3 to both sides. So my x value of the vertex is -3. Yes, ma'am. Say that one more time. No, if the plus 3 was outside of the radical, it would just be 0 as your x value for the vertex. But your y value would change. So it wouldn't be 0, 0. It would probably be like 0, 3 or -3. So with the y value, I'm going to plug -3 back into my function. So negative cube root -3 minus or plus 3. So -3 plus 3 is 0. What's the cube root of 0? 0 times a negative? 0. So the y value of my vertex is 0. So my vertex is at the point 3, 0, or -3, 0, sorry. So that's the first thing I'm going to graph. That's also going to be what I base my other points around. Now, before we get into finding more points, let's talk transformations real quick. What transformations are going to happen to this graph based off of the parent function? So it will reflect over x. which in reality, with a cube root function, the reflecting over x just means it's going to go in the opposite direction. So this one starts low, gets high. This graph would start high, get low. What's the other transformation? Left 3. So that should give us an idea of what our graph is going to look like. So now I'm going to look at my perfect cubes. All right, so this gives me the perfect cube is 0. What would give me a perfect cube of 1? So what x value would give me a perfect cube of 1 under the radical? So if I plug it back into this function, what x value would give me 1 under this radical? -2. All right, if I plug -2 back in, what's the y? So it would be the cube root of 1 times a negative. So it's what? -1. All right, what would give me the perfect cube 8 under the radical? What x value? 6, not 6, 5. All right, if I plug it back in to get my y value, so 5 plus 3, that's 8. Cube root of 8 is 2 times the negative is what? -2. Then the opposite direction. So we need -1 and 8. What x value would give me a cube root or the perfect cube -1? So what x value, if I plug it into my function, would give me -1 under the radical? No, we did 1. I want -1. So in other words, I want it to look like this after I plug it in. -4. So if I plug that in, cube root of -1 is -1 times the negative is what? +1. What about -8? What can I plug in for x that would give me -8 under the radical? -11. Plug that in. -11 plus 3 is -8. Cube root of -8 is -2 times the negative is what? 2. So these would be the points I would graph. So I have -2, -1, 5, -2, 4, 1, and then -11, 2. So my graph looks like this. So guys, what I did is this right here should be how you find your x values. You're asking yourself, what x? So what you need to ask yourself every time is, what x would give me this number? All right. And I'm just talking about under the radical. So in other words, under the cube root, what x would give me that number under the cube root? So that's why I did that. So when you're trying to come up with x values, so you don't have to keep testing a bunch of them to see if you get perfect cubes, that's how you should think about it. Any questions on that? All right, real quick, domain and range. It'll be all real numbers for both. So cube root graphs will probably be the easiest thing you ever do with domain and range because it's going to be all real numbers for both every time. It's square roots that you have to worry about. All right, any questions on the graphing side? So again, there's two ways you can do it. You can either do it through the table method or you can do it through the transformation method. All right, but if you do it through the transformation method, you have to know what the parent function looks like. And again, that's if you do it by hand. All right. So, next thing. Now we're going to write the equation from the function. All right. So, remember, we kind of talked about this yesterday, but typically with a cube root and a square root graph, a square root, its general form looks like that of vertex form for a quadratic. So it's A is the square root of something x minus h, and then with plus k on the outside, where hk is still your vertex. Cube root, exact same thing, just with a cube root instead of a square root. All right. So, first things first, let's look at example 6. What type of graph is that to start out with? Is that going to be a cube root or a square root? It's just going to be a square root. So we know we're going to have something y equals something square root. All right. Now, let's identify the vertex. Where is my vertex? -6, 0. All right. So it's at -6, 0. So HK is equal to -6, 0. So if I plug that in to this function over here and evaluate it, what would it look like here? So x plus 6, and then is there a k value or anything added outside? No, because add 0 is the same thing. Now, we then need to make sure our a value isn't anything. So first off, will our a value be negative? No. Based off the direction the graph's going in, it's definitely not negative. All right. So let's find another solid point to help us figure out if the a value is 1 or if it's something else. So find the next closest solid point, which is right here. So this is the point -2, 2. So think about when we did quadratics. Who remembers what I can do to get my a value based off of another point? Plug it in for x and y, solve for a. So this would be 2 is equal to a square root of -2 plus 6. And then I'm going to evaluate it. So I get 2 is equal to a square root of 4. What's the square root of 4? 2. So this would be 2 is equal to 2a. Divide both sides by 2. A is equal to what? 1. All right. So that means that we just don't have a value in front of our square root. But you can't always assume that it is 1. In this case, it is, but not always. So our final answer is y is equal to the square root of x plus 6. Now, what will be the domain and range of this graph? So what would the domain be? So the domain, what's my lowest x value? -6. And where does it go to? Infinity. What about the range? What's my lowest y value? 0 is. And then my highest is infinity. Not always, because if that vertex gets moved, then it'll change. So if you notice, it's based off of the vertex. So your domain and range, if you notice, the domain is whatever the x value of the vertex is, and the range is the whatever the y value of the vertex is. All right. So that was the square root graph. Now let's look. Yes. You're just looking at me. Never mind. So now let's look at the cube root. So we know this is going to be something cube root. So y equals something cube root. Where's my vertex? So remember, it's usually in that weird squiggle. It's like in the middle of that squiggle. So it'd be at 2, 5. So right here. So HK is at 2, 5. So if I plug that into here and evaluated it, what would it look like? Good. Now, remember, this is our tentative because we need to double check that the A value is 1. So I need to find another pretty point. Someone name me one pretty point. So what I mean by a pretty point, it means it lines up perfectly with 2 lines. So 1, 4, I'm going to use that one just because I heard it first. So 1, 4 is another pretty point. So we're going to plug that in for x and y and evaluate. So I have 4 is equal to a cube root 1 minus 2 plus 5. What's 1 minus 2? Negative 1. So I got the cube root of negative 1 plus 5. So this would be negative a, because the cube root of negative 1 is negative 1, plus 5. Subtract the 5 to both sides. I get negative 1 is equal to negative a. Divide by negative 1. 1 is equal to a. So my final answer would be the cube root of x minus 2 plus 5. Now, what would my domain and range be? All real numbers for both.
How did you get from 4 equals a cubed square root negative 1 plus 5 to the 4 equals negative a?
Because what's the cube root of negative 1? Negative 1. So negative 1 times a is just negative a. Because you're technically multiplying these two. So in other words, this would have been the same thing as a times negative 1 plus 5. And then that's how I got the negative a. How'd I get x minus 2? So it's just what we originally started with. So right here. And then I plugged in the a value. So remember, we got the vertex and we just plugged it into this formula. Because remember, the vertex is hk, so if you plug it in verbatim and for h and k, you get the general form at the very least. You just need the a value. So it's like when we did vertex form with quadratics. Does that answer the question? All right. Okay. We'll still do some more practice with it, but now, like I said, when it comes to square root graphs, we can essentially figure out what the domain and range is without even having to graph it. All right. Cube roots, it's always going to be all real numbers, regardless of what we do. Square roots, I already kind of brought this up, but with square roots, when we're trying to find the domain of a square root function. All right, so let's look at this function right here. So square root of x minus 4. All we really need to know is that you cannot take the square root of a negative. Well, you can, but we know it's imaginary, which would not show up on a graph anyway. All right. So that means that the lowest value x minus 4 can equal is 0. So in other words, this is our lowest y value. Or our lowest, not really the y value, I would say the radicand. So that can be the lowest number under the radical after we evaluate. So if we set whatever's under the radical equal to 0 and solve, we get our lowest value of the domain. Because our domain has to be greater than or equal to 0. So if I solve, I add 4 to both sides. So x has to be greater than or equal to 0. And that right there, not 0, Lord, 4. And that right there would be our domain for that function. Now, what is that in terms of interval notation? So what is x is greater than or equal to 4 in interval notation? Good. Bracket 4 to infinity. So remember, you can write it either way. So let's do some examples where we're just finding the domain. All right, so first off, for example 8, I'm going to set 2x plus 5 to be greater than or equal to 0. What's my next step? So I'm solving for x. So we're going to subtract 5 to both sides. I get 2x is greater than or equal to negative 5. Then what do I do? Divide by 2. So x has to be greater than or equal to what? Negative 5 halves. So this is our domain. What is it in terms of interval notation? Comma what? Infinity. And then remember, infinity always has a parenthesis. So either one of those I would accept, but you need to be able to recognize both. Because if it was on a test, you never know, like if it was a multiple choice question, you never know which way they're going to give you. Also, if I ask you to write it a specific way, I expect you to write it that way. All right, what about example 9? What do I do? So 2/3 x minus 8 is greater than or equal to 0. Add 8 to both sides. So I don't necessarily want to divide by 2/3. What am I technically doing? So this is like a way back math 1 concept. Multiply by the reciprocal. So I'm going to multiply by 3 halves. If you need to, put that 8 over 1. 8 times 3 is 24. 1 times 2 is 2. So I have 24 over 2, which is just what? 12. So that's an inequality form. What about interval notation? What would it be? It'd be 12 to infinity. Now, in this case, if we plug it back in, our y value would be 0. All right? But that's not always the case. So if I ever ask you to find the range, all you need to do is plug it back in for x and see what you get. For both of these, it'll be 0, so I'm not going to bother. But some of the ones down here that I want you guys to try out, they may not be just 0. All right? So I'm saying for the range, so for the range, you need to plug in x value back into original function. All right. So what I want you guys to do, I'll give you guys about 5-6 minutes. Try A through E. Guys, everyone should be trying these. At the very least, try to get the domain. So in other words, so whatever's under the radical equals 0. Thumbs up if you're ready. Give you guys about 2 more minutes. And I will be calling people, so make sure you do it. All right. It's just big. No. All right. Shh. All right, let's talk about it. All right, so let's go with William. How do I need to find my domain for letter A?
I just assume it's just like non-negative there after the x. I'm just assuming it's like a positive one there, so I need two values to do it. What I did was you have to talk by 5. It was just x and 1, so I just flip the sign to make it 1.
Not quite. So remember, guys, everything's based off of your domain. Everything is based off of what's under the radical. And you're going to set it equal to 0 or greater than or equal to 0. All right. So for this one, you set up as x is greater than or equal to 0. Which, William, do I have to do anything for that? No, there's nothing to solve for. So what would it be in terms of interval notation? So would 0 be my lowest or highest y value? Not yx, sorry. Lowest. So we'd start with 0. It has a bracket because it's equal to. Where does it go to? Infinity. Now, range. Let's go with Blake. How would I find my y value for range? Not quite. Right. We plug our lowest x value back in to get our y value. So if I plug it back in, I have 5 square root of 0 is equal to y. Or it has to be greater than or equal to y. So square root of 0 is 0 times 5 is just 0. So y has to be greater than or equal to 0. So if y is greater than or equal to 0, how do I write that in terms of interval notation, Blake?
Bracket 0.
Mm-hmm.
Will it just be the infinity part?
Yep. Good. All right, so let's go to the next one. So let's go with Reagan.
I'm really
All right. So with domain, what did I just say we have to always do? Said equal to 0 or it's greater than or equal to 0. So x plus 1 is greater than or equal to 0. All right. Now, what will we do? But wait, what type of graph is this? It's a cube root. And what did I always say is the domain for a cube root? Yep. What's the range? All real numbers. So this would be how you would set it up if it was a square root. It would also be how you would set it up, but with an equal to if you wanted the vertex. But you need to make sure you pay attention to what type of root it is. All right, so Reagan, you're gonna help me with C. So what I need to do first? Mm-hmm. So x minus 7 is greater than or equal to 0. Now you're solving for x, so what do? So you get x is greater than or equal to 7. So what would that be in terms of interval notation? So is 7 your lowest or highest x value? Lowest. So you write the 7 first. And use a bracket because it has an equal to. What's your highest x value? Infinity. All right. So let's go with Shelby. How do I find my range? Right, we plug it back in to solve for y. So we get y has to be greater than or equal to negative square root of 7 minus 7. Which would give me what, Shelby? Right, y has to be greater than or equal to 0. So how do I write that in interval notation? Good. All right. Any questions so far? Now, another thing I want to mention is this negative right here. What does that do to my graph? Flips it over the x-axis. Now, that doesn't necessarily mean that our x value changes. All right, but it could possibly change our y value. So let's just double check it to be safe. So if I do a quick graph into Desmos, I'm just going to graph the entire square root function that we have verbatim. So y equals negative square root x minus 7. So our domain stays the same, but what happened to the range? It flips. All right. So just something to note. So this would actually be y is less than or equal to 0. All right, because if you think about it, if I actually wrote this out, y is greater than or equal to negative 0, which I know there's no such thing as negative 0, but humor me. All right. We end up having to do what? Divide by a negative, which does what to the sign? Flips it. So this would flip. No, domain's correct. But just something to note, if you see a negative in front of your square root, your range is going in the opposite direction. So negative in front of square root, range is going as y is less than some number, or from negative infinity to some number. All right. So let's go, Amelia. Next one. Okay. Well, how do I get the domain? What do I need to do first? So set it as greater than or equal to 0. Like you mean like for E when we get down there? Yeah, it still affects it. If your A value is negative, essentially. So what would my range be, Amelia? Not range, I meant domain, sorry. Good. So what would that be in interval notation? Yes. 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 So when you're doing domain, you ignore anything that's outside of the radical. Range is when you have to actually include it. All right? Because range, you would end up plugging it back in. So let's go with Lucas. If I plugged it back in for the range, there's no negative, so we have y is greater than or equal to. So how would I plug it back in for the range?
Wait, so are you plugging in the -2?
Yep. So -2 plus 2, and then the -3. So if I evaluated that, Lucas, what would I get?
Would it be square root of 0 minus 3?
Mm-hmm. Which is what?
Would that just be -3?
Yep. So y is greater than or equal to -3, and what is that in interval notation?
Bracket -3 infinity.
Good. All right. Let's go, Audrey. Domain for the last one. Right, so x minus 1 is greater than or equal to 0. Solve it. X is greater than or equal to 1. How do you write that in interval notation? Yeah, bracket 1 infinity. I don't know why I wrote -1. There we go. All right. Now, make sure you pay attention to what's in front of our radical. So, Eli, first off, is my range going to be going from negative infinity to some number or from some number to infinity? So in other words, if I want to set y is greater than or equal to our function, or y is less than or equal to our function?
Greater than or equal. No, less than.
Why?
I didn't get that point. So.
Well, what's in front of the graph?
-2.
A negative. So since it's negative, we defer to that. So when I set this up, I have y is less than or equal to -2 square root of what?
X minus 1.
Not x minus 1, but because I'm trying to find the value for the range. We use our domain value. So 1 minus 1 plus 6. So this would be -2 square root of 0 plus 6 less than or equal to y. So what is that, Eli?
You have the 6 to the other side, right?
No, we're just evaluating. Nope. What's -2 times 0?
0,
Plus 6.
6.
There you go. So y is less than or equal to 6. So how would I write that in interval notation?
Infinity is, or, yeah, infinity.
Negative infinity to,
6.
there you go. So guys, yes. Because if it's less than, that means 6 is your biggest number. So you got to ask yourself, is my number that I found the biggest number or the smallest number? If it's the biggest number, you start with negative infinity. If it's the smallest number, you start with that number, go to infinity. Yes, Sailor.
So if there's a number and besides like the negative
Uh-huh.
in front of the square root or whatever,
Uh-huh.
does that number just always cancel out?
What do you mean?
Because like we didn't need to use the negative two, because we did positive 1 minus 1, but like will it normally cancel out like that?
Typically, yeah. Just because we found when x was the x value that gave us 0 underneath the radical.
Yeah.
So if you multiply anything by 0, yeah.
But so like we don't really need to focus on that number normally.
Not really, but I would still, like, if you're plugging back in, include it because you never know. I don't want to give you like a definitive yes because there are extenuating circumstances. Yes, Reynolds.
So why don't you use like the -3 and the 6 like on the outside?
Because for domain, all we're focusing on for domain is we do not want a negative number at all to fall under this after we evaluate. All right? So in other words, if we evaluate this, we plug in some number for x, and we evaluated that number minus 1, we cannot get a negative number. Because if we do, a square root of a negative number gives us what?
Imaginary number.
An imaginary number. So remember, a square root of a negative, like -1, that gives us I. Which, does that show up on a graph?
No.
No. So that's why. All right?
But it's positive.
Because we're trying to figure out where it's positive. Or what the lowest value could be. Because the only thing.
Is positive when x is 2.
Oh, that doesn't matter. I just use negative, that number minus 1. So this would be some number plus 2 and not be a negative number. If we evaluated it. Okay, so that's why we set it as greater than or equal to 0, because we know for a fact that we can take a square root of 0. All right, but as soon as we get to like say square root of -0.00001, start being imaginary numbers. All right, that's like let's say I had like an infinite number of zeros and then like a singular 1 at the end. That's when you start getting, but it's negative. That's when you start getting imaginary numbers. So we can't go past 0. So that's why we set this equal to 0, so that we know what the lowest x value is. Does that make sense?
So I'm just confused why you don't use minus.
That's what I did originally.
Yeah, it's I understand.
So this does not affect over here. Alright? The negative is what's gonna change the range. When it comes to domain, it's only based off of what's under the radical.
Like, why is it only based on what's under the radical? Like, why do you not include the rest of the equation?
Okay, because here's how functions work. Alright. The radical is what I like to call it a type of bracket. Meaning, it's like parentheses. Alright. Anything under the bracket specifically affects the x value. Alright. Now, anything outside of the bracket specifically affects the y value. Alright, because remember, input versus output, whatever we input gives us the output. So we're trying to find an input that won't screw up our output. And that's why we only focus on what's under the radical, because the radical, our bracket, is what can screw us over. Alright? Because let's say I had just like the x plus 2 squared minus 3. Alright? Then it doesn't matter, because that's why the domain here is always all real numbers. Because a square won't screw us. A square root will screw us. Alright? Because there's more stipulations with the square root. Does that make more sense? Alright. So I'm gonna call it for today. Your homework for tonight is pages.
Yeah.
Your homework for tonight is 32, 33.
I've just been like.
You also have that delta math from yesterday or from 2 days ago due tonight. So if you haven't done it yet, you need to get that done as well.